Hi everyone, in this series of videos we are going to check out backpropagation in Pytorch, and we are going to have 3 videos. In this first video we will first look at forward propagation, then in the next video we are going to look at backward propagation, then in the video after that we will see gradient descent. So this example is going to have 3 layers of 3 neural network layers, and we know that in each layer, say layer L, that layer has number of input features, output features, which can be say 1 and 2, for example, meaning that your input has one feature and you want an output that has 2 features. So in each layer you calculate ZL, and ZL is calculated using this formula: L minus 0 WL transpose plus BL. This is the bias, weight, and also the activations from the previous layer. Then you can say AL, you calculate the activation of that layer using, say, maybe a nonlinear function, ReLU, for example, ZL. Or you can, instead of using this formula, you can just say AL is ZL. So you can achieve this in Pytorch using, say, touch.nn.linear with linear. I made a video about this, so I'm going to link it in the description about touch.nn.linear. And the example that we are going to take a look at is, say, we have a tensor. I hope you can see. Okay, let's call it x, which is the same as a 0, and the dimension of this input is bs by f. This can be 1 and this can be 2, for example. So we have, means bs is batch size, so we are just going to have one example, and f is the number of features. So it's much more like this. We just have 1 row and 2 columns. Each row takes a single example. So as I mentioned, we are going to have 3 neural network layers. Okay, so in layer 1, we should specify the number of input features, say f, has to be f actually, and then the output features, say f1. Then we need to compute z1. We are going to use these formulas here: is 0 w1 transpose plus b1. So for each layer L, the dimension of the weight is always f1 by f, and dimension of b1 or bl is 1 by f1. So A0 has a dimension of bs by f, and the transpose of w1 is f by f1. Okay, then after multiplying this, you end up with a tensor that has a dimension of something like this. By the way, these are all dimensions, not tensors. These are the dimensions of the tensors after the operations or during the operations. Then when you add this, you end up with a tensor of bs by f1. Okay, then you can say AL is ZL, because we will not apply any ReLU, so we are just going to say A1 is Z1, so A1 is Z1, and they both have the same dimensions. But don't forget, these are all tensors. I mean, the result is a tensor that has a dimension of PS by F1. Okay, so let's move on to layer 2. Layer 2 must have an input features of F1, then output of F2. You can choose anything. Then compute Z2. Z2 is A1 using the formulas here. Then W2 transpose plus B2. A2 has a dimension of F2 by F1. We know that A1 has a dimension of BS by F1. The transpose of W2 is F1 by F2. B2 has a dimension of 1 by F2. So maybe I should, okay, I wanted to write the dimension of BL in here, but we don't need to. For each layer, for layer L, the dimension of BL is always 1 by F, the features of that layer. Alright, so in this operation, when you multiply this, you end up with something like this: PS by F2, then plus 1 by F2. When you add them, you end up with something like this: BS by F2. In here, we are also not going to apply, we will not apply any activation, so we're just going to say A2 is Z2. This is the resulting tensor. In the last layer, L3, in is F2, out, let's call it F3. Alright, so Z3 is A2 W3 transpose plus B3. As always, this is F3 by F2. This is the dimension. A2 has a dimension of BS by F2, right? From here. Then the transpose of W3 is F2 by F3 plus 1 by F3. After this multiplication, you end up with something like this: 1 by F3. Then addition is F3 BS by F. Sorry, this is F3, right? BS by F3. Then A3 is always is the same as Z3. We are not going to use any ReLU. If we had used ReLU, for example, this will have been A3 is the ReLU of Z3. But we are not using ReLU, so forget about this. The same, similarly in the previous layers. So we are going to take a look at this. We will use this information to compute the gradients of the weights and biases with respect to the gradients with respect to the weights and biases in the next video. Thank you. Bye bye. Maybe one more thing. A3 is actually Y hat. A3 is your prediction. Yes, Thank you. Bye bye.